InTAC is a software-based process control suite that replaces PID and provides low maintenance, high performance, and easy-to-use control for industrial systems. In this video, you will learn how the InTAC offering for Siemens TIA Portal can improve performance, simplify commissioning, and reduce maintenance. Let's walk through a simulation of the commissioning process. During this simulation, you will observe the behavior of the variables on the screen. White indicates the set point, orange is the process variable, and blue is the manipulated variable. You can set the value of the manipulated variable in the purple box, and you can specify a value for the process disturbance in the yellow box. Because we're running a simulation, we need to provide initial values for the process gain, time constant, and dead time. When you commission InTAC for your process, these values will be automatically identified. To start the simulation, ensure that the controller is in manual mode, which allows us to change the manipulated variable. Provide a process set point. Enable control and PV noise, which in this situation will mimic the noise in your real-world process. PID has been the industry standard for process control since the 1920s. Despite the fact that it's been around for a long time, it's still pretty challenging to use. It's difficult to tune PID for all the dynamics that can occur in your process. The tuning process is complex, time-intensive, and iterative. In addition, PID controllers drift over time, which affects the performance and ultimately your end product. Once the process variable settles, enable Identify. InTAC has a single tuning parameter called bandwidth that is automatically identified through the commissioning process that we're showing you right now. Unlike PID, this single gain is effective across varying process dynamics. InTAC Identify introduces a step input and automatically identifies the system gain, time constant, and dead time. InTAC Control automatically calculates a recommended bandwidth. Once the identification process is complete, transfer the gain, time constant, dead time, and the recommended bandwidth values to the controller. Now let's test the controller and make sure that it's performing well. First, we'll enable automatic control. For processes that have more than a 5-second dead time, use your own external filter. Since we're running a simulation, we've built our own external filter that we can set through the portal. Let's introduce a set point change and look at the controller's response. Notice the impact of the external filter. It reduces the process noise. Here we see a smoother control signal. We want the controller to respond quickly to set point changes, and there should be no overshoot. We see that desired behavior here. Now let's return to the original set point. InTAC is ideal for controlling first-order plus dead time systems, as well as first and second-order motion systems. With InTAC, you can control velocity, position, temperature, level, and flow. As the process variable returns to the original set point, we see a quick response with no overshoot. Let's see how the controller behaves when we introduce a disturbance. In this simulation, we'll set a disturbance value and add that disturbance to the process. InTAC is based on a technology called active disturbance rejection control. This technology enables InTAC to compensate for system disturbances. Process disturbances occur all the time in the plant environment. They might be caused by things like variations in raw materials, ambient temperature changes, or even enhancements that are made to the plant. PI controllers will drift over time and their performance will degrade. That's why they need to be retuned on a regular basis. Because InTAC can automatically compensate for disturbances, there's no need to retune the controller, ever. We installed InTAC on a hose extrusion line more than 4 years ago. The process is still operating at peak performance, and the InTAC controller has never been retuned. Imagine what impact this could have on your maintenance budget and on the quality of your process output. Notice how quickly the controller returns to the desired set point when the disturbance is applied and when it's removed. InTAC provides a recommended bandwidth, but how do we know that the recommended bandwidth is the best value? Let's test it. First, we'll increase the bandwidth by 25% and introduce a set point change. Notice that the controller responds quickly but overshoots the set point. Let's return to the original set point. InTAC is really easy to install. The InTAC library is a collection of function blocks that are dropped into the device tree and can run in parallel to PID. This is really helpful for comparing performance, and it allows you to roll back to PID control if you need to. But why would you? Based on the controller's response to an increase in bandwidth, we see that the original recommended bandwidth is much better than the larger value. What if we decrease the original bandwidth by 25%? We've seen that the commissioning process is really quick. InTAC automatically identifies the system gain, time constant, and bandwidth. This means that the plant will experience minimal downtime when installing this controller. When you compare the InTAC controller to your existing PID control, you'll see how well it adapts to changes and variations in your process. Optimized performance means that your plant will produce consistent, quality product. At this lower bandwidth, we don't see any overshoot, but it takes much longer to reach the set point. We encourage you to run these tests yourself. In this simulation, we see that the recommended bandwidth is spot on. In this video, you've seen how easy it is to commission InTAC industrial tuning and control. We've highlighted InTAC's advanced performance, and we've discussed the maintenance benefits. InTAC is available for Cymotion and PCS7. Contact your local Siemens value-added reseller and see what InTAC can do for your plant.